Let's see. In the previous class that we discussed about a charge particle moving in a magnetic field, right? That is like a cyclotron concept, right? So this one we have discussed. Then we discussed about the total force acting when it is moving in a both electric field and magnetic field. Then we discussed about the concept of uh, charge particle moving other than 90 degree or at an any angle theta with respect to magnetic field. It is going to follow the path of helical shape. That is called as helical path. Then we discussed about based on this. There is we need to discuss one problem. I think so. Wait a minute. I'll go to the concepts. So yes, this much we have discussed in the previous class. Okay. So this is what exactly we got. So once again, I will revise that time period and radius of a particle which is moving in any angle at any angle to the magnetic field. So see here, is it audible properly?
Yes, sir.
Okay. Here, so if the charge is moving at any angle theta with respect to magnetic field, so here it is the so this along x-axis there is a magnetic field. If an enters at an angle theta with respect to the magnetic field with respect to x-axis, it is going to follow this helical path. As in, if you look at from the front side, it looks like a circular motion only. But because of this parallel component, velocity component which is parallel to the magnetic field is not going to experience any magnetic force. But the velocity component which is perpendicular to the magnetic field is going to experience a force. Therefore, the parallel component is going to carry the charge in a forward direction, and the perpendicular component experiences the circular path. It moves in a circular path due to the magnetic force. So due to that, radius of the path followed by that particle is given by mv divided by qb, where mv is nothing but v is the velocity which is responsible for the circular motion is perpendicular component. Therefore, we write that as mv sin theta divided by qb. Okay. Then similarly, that is as this is following circular motion and it is going forward. As it is going forward, this forward motion in one complete oscillation or one complete rotation. ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಹಿಂಗೆ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಮತ್ತೆ ಬಂದು ರಿಟರ್ನ್ ಬಂದು ಮತ್ತೆ ಇಲ್ಲಿಗೆ ಬಂದು ನಿಂತಿತ್ತು ಅಂತಂದ್ರೆ ದಿಸ್ ಒನ್ ಏನು ಫಾರ್ವರ್ಡ್ ಮೋಷನ್ ಏನದ ದಿಸ್ ಫಾರ್ವರ್ಡ್ ಮೋಷನ್ ಲೆಂತ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪಿಚ್ ಲೆಂತ್ ಅಂತ ಕರಿತೀವಿ. We call this one as pitch length. That pitch length is given by time period. Time period is nothing but time taken for complete one revolution rotation or one complete uh, circular motion. If it starts from here and it goes and ends here, so this is going to be from front side. It looks like this. ಹೌದಿಲ್ಲ, ಒಂದ್ಸತಿ ಒಂದು ಕಂಪ್ಲೀಟ್ ರೆವಲ್ಯೂಷನ್ ಸರ್ಕ್ಯುಲರ್ ರೆವಲ್ಯೂಷನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಸೊ ಟೋಟಲಿ ಎಷ್ಟು ಬರ್ತದೆ ಅದು the time taken for one revolution is given by t is equal to 2 pi into m divided by qb. So this is independent of velocity term. Okay, that is given by t is equal to c. T is equal to total length is going to be 2 pi r, then velocity is going to be v. So if you substitute that radius part here, that is 2 pi r equal to mv divided by qb into v. This v get cancels. We left with only 2 pi m divided by qb. That part here we have got, that is 2 pi m divided by qb part. This is independent of velocity term. Whether you are moving in a perpendicular or whether it is what is the parallel component of the velocity, time period will be same. So if you're taking the time period, so as it is revolving, complete one revolution ಆಗಬೇಕಾದ್ರೆ ಎಷ್ಟು time ತಗೋತದೆ, at a time forward ಬರಬೇಕಾದ್ರೆ ತಗೋತಾ ಇದ್ರಿ. Therefore, horizontal velocity component, the time period that is going to give us, that is the total distance covered in a forward direction. That distance covered in forward direction is defined as pitch length, that is v cos theta into 2 pi m divided by qb. V cos theta into 2 pi m divided by qb. Okay, so time period is substituted there. The next concept is magnetic moment. Next concept is magnetic moment. magnetic moment. So what do you mean by magnetic moment? See, if a current carrying conductor is moving in a circular path, if that current is moving in a steady current is moving in a circular wire, okay, then it is going to produce a magnetic field in this direction, right? The magnetic field will be induced. So as this magnetic field is going to pass through a cross-sectional area of this, that circular path, then that is going to give us a flux which is coming out of that part. The flux coming out of the area or magnetic field coming out of the area is called as magnetic flux generally. And this is defined as this current is flowing uh, through a cross-sectional area. That is current flowing through a cross-sectional area is given by that is I into E. That is going to be defined as magnetic moment. So here we define sometimes mu is equal to I into E. Similarly, this is applicable also in case of nuclear and atomic parts. So we get their atomic magnetic moment. Okay, magnetic quantum number here. And moreover, as this magnetic moment, so if anything current element, ಇದಕ್ಕೆ ಯಾವುದೋ ಒಂದು current element circular path ಒಳಗಡೆ move ಆಗತ್ತಿತ್ತು ಅಂತಂದ್ರೆ, so it is going to produce a magnetic field. So its magnetic moment is defined as in the direction of magnetic field that is given by mu. Mu is a vector quantity. Remember, mu is a vector quantity. So we generally write like this. If the current is flowing in this direction, magnetic moment will be in this direction. See, even the other magnetic moment other current flow agatati, or let us take the electron at over. Electron in nucleus utla move agatati, the nucleus and core. Either magnetic moment about your direction atati, e direction agati. Okay. As this is magnetic moment e direction agada. If you apply an external magnetic field into it, external magnetic field is ಮೇಲೆ apply ಮಾಡಿದ್ರಿ ಅಂದ್ರೆ ಏನಾಗ್ತೈತಿ ಇಲ್ಲಿ ಏನೂ ಆಗಂಗಿಲ್ಲ. ಅಕಸ್ಮಾತ್ ಅದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಈ ತರ ಇತ್ತಂದ್ರೆ this magnetic moment ಯಾವುದೋ ಒಂದು random direction ಆಗದ. So wait a second. Yeah. So magnetic moment ಯಾವುದೋ ಒಂದು random direction ಆಗದ. But I will take like this. So let us take this magnetic moment in this direction because of its current flow. So current is moving in this direction. ನೀವು right hand thumb rule ಯೂಸ್ ಮಾಡಿ. ಕರೆಂಟ್ ಹಿಂಗೆ ಕರ್ಲ್ ಮಾಡಿದ್ರಿ ಅಂದ್ರೆ ಥಂಬ್ ಯಾವ ಕಡೆ ಹೇಳ್ತದೋ ಅದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಇರ್ತೈತಿ. Okay, it's a magnetic moment produced by that current element. So ಅಕಸ್ಮಾತ್ ಯಾವುದೋ ಒಂದು magnetic field ಅನ್ನು horizontally apply ಮಾಡಿದ್ರಿ like this. The magnetic moment is applied on this. Then ಏನಾಗ್ತದೆ ಇದು? See, this makes an angle, certain angle theta with respect to magnetic field. So if I take this is a theta made with magnetic field, right? So ಇದು magnetic moment to magnetic field direction ಒಳಗಡೆ orient ಆಗಕ್ಕೆ try ಮಾಡ್ತೈತಿ. So magnetic moment try to turn into a magnetic in the direction of magnetic field. Therefore, see, as this you are applying the magnetic field, so automatically ಏನಾಗ್ತೈತಿ ಈ ಕಡೆ turn ಆಗ್ತೈತಿ, ಕರೆಕ್ಟಾ? Because of the turning in turn ಆಗ್ತದೆ, it creates a torque in this torque. So torque acted because of rotation. So torque is given by that is m magnetic moment cross b vector, or we can define that as mu vector cross b vector. That gives the torque which is going to rotate that magnetic moment in the direction of applied field. ಇದಕ್ಕೆ ಇದೇ ಸಣ್ಣ magnetic moments ಗಳಿಗೆ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಒಂದು ಯಾವುದೋ ಮಟೀರಿಯಲ್ ತಗೋರಿ. ಈ ಮಟೀರಿಯಲ್ ಒಳಗಡೆ ಅಟಮ್ಸ್ ಅದಾವ, ಕರೆಕ್ಟಾ? ದೇರ್ ಆರ್ ಲಾಟ್ ಆಫ್ ನಂಬರ್ ಆಫ್ ಅಟಮ್ಸ್ ದಟ್ ಐ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ಡ್ ಇನ್ ದ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಪಾರ್ಟ್. ನಿಮ್ಗೆ ನೆನಪಿರ್ಬೇಕು ನೋಡ್ರಿ. ಇವಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಇದ್ರ ಸುತ್ತು ಸಂಬಂಧ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂವ್ಮೆಂಟ್ ಬರ್ತೈತಿ. ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಸುತ್ತು ಸಂಬಂಧ ಅಟಮ್ಕ ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂವ್ಮೆಂಟ್ ಬರ್ತೈತಿ. ಇಲ್ಲೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಸುತ್ತು ಸಂಬಂಧ ಇದಕ್ಕೊಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂವ್ಮೆಂಟ್. ಇವೆಲ್ಲ ರ್ಯಾಂಡಮ್ಲಿ ಅರೇಂಜ್ಮೆಂಟ್ ಆಗಿರ್ತಾವೆ, ಕರೆಕ್ಟಾಗಿ ಈ ಥರ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂವ್ಮೆಂಟ್ಸ್ಗಳು, ರೈಟ್? So ಇಲ್ಲಿ ಯಾವಾಗ application of the magnetic field ಅನ್ನು apply ಮಾಡ್ತೀವಿ, all the magnetic moments will be, they are going to orient in the direction of applied field. ಇಲ್ಲಿ applied field ಒಳಗಡೆ ಎಲ್ಲಾನು magnetic moments ಗಳು ಏನಾಗ್ತವೆ ಈ ತರ orient ಆಗಿಬಿಡ್ತಾವೆ because of the application of magnetic field. So this rotation of the magnetic moments in the direction of the applied field is generally called as ಏನಂತ ಕರಿತೀವಿ, torque, or this is called as magnetization. We call this one as magnetization. And due to the rotation of these magnetic moments, so you can experience that rotation. Therefore, that rotation is due to that is torque acting on that particle. That is by taking the cross product of magnetic moment and magnetic field. And similarly, as this see, let us consider if what is that? Let us consider the magnetic moment. Okay. If I consider, for example, the electron system tour. Okay. So electron nucleus theory, nucleus electron sutatadu. That is in the circular path. That is, let us consider this electron. As because of this electron motion, there is a current flow ಆಗ್ತೈತಿ. ಈ current flow ಆಗೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ circular motion ಒಳಗೆ ಮೂವ್ ಆಗುತ್ತದೆ. As it is moving in a circular motion, so it is going to experience the current. Then there is a magnetic moment mu, and moment mu ಅಂತ ಕರಿತೀವಿ. Okay. So magnetic moment mu ಅಂತ define ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ, see, magnetic moment mu is given by its I into E, I into E, or I can define that as Q divided by time into E ಅಂತ ಕರಿಬಹುದು. Or you can also define this one as Q divided by time under one time taken to complete one revolution. I will define that one as Q into E divided by T can be written as 2 pi r is circular motion of the divided by velocity. Therefore, I can rewrite this one as that is Q. What is the cross sectional area of the circular path? That is pi r square. Then divided by 2 pi r into V. E r E r cancel out, pi cancel out. We left with QV divided by QVR divided by 2. So this is what the magnetic moment of an electron revolving around the nucleus. And similarly, do you know there is, as because of its motion in the circular motion, it is going to experience an angular momentum. Angular momentum. So angular momentum. So how do you define the angular momentum here? Angular momentum L is equal to its mass of the electron into MOER. We define that one as MOER. Therefore, mass of the electron into velocity into R. So if you take the magnetic moment is also vector quantity, angular momentum is also vector quantity. If you take the ratio of magnetic moment to angular momentum, magnetic moment to angular momentum, angular momentum. What do we get here? So that is mu divided by L, mu divided by L vector, right? So what is this mu? Mu is given by that we wrote, that is QVR divided by 2. That is mu is equal to QVR divided by 2. The whole divided by L is equal to MVR. So see, this VR get cancels. I left with Q divided by 2M. Yes, this is the relation of ratio of angular momentum to that is magnetic momentum. So this they may ask this question. Okay, relation between angular momentum of electron revolving on the nucleus to its magnetic moment. Done with this? Then next, Gauss law of the magnetic field. Then Gauss law of the magnetic field. So Gauss law, how to define the Gauss law? Gauss law is nothing but actually the magnetic flux coming out of a closed surface. So or any flux, flux, there is flux coming out of or diverging from a closed surface. So let us take one ಯಾವುದೋ ಒಂದು current theory, for example circular loop theory or anything, whatever you take the magnetic moment. Let us take a magnet theory, a small bar magnet theory. So let us call this south and north pole. So magnetic field changa north to south and south to north. So ಈ ತರ one part to another part, ಒಂದು ಕಡೆ ಎಂಡ್ ಆಗ್ತಾವ, ಒಂದು ಕಡೆ ಎಕ್ಸಿಟ್ ಆಗ್ತಾವ, ಒಂದು ಕಡೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾವ, ಒಂದು ಕಡೆ ಎಕ್ಸಿಟ್ ಆಗ್ತಾವ, ಕರೆಕ್ಟಾ? So this is what the magnetic field around this magnet. But see, generally if you consider a Gaussian surface around this, if I consider the Gaussian surface around this what is that? Uh, bar magnet. So what is the magnetic flux which is coming out of this? See, if for example ಈಗ ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ತಗೊಂಡಿವಿ ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಂದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯಾವತ್ತು ಹೊರಗಡೆ ಬರ್ತದೆ, ಡೈವರ್ಜ್ ಆಗ್ತವೆ. So if you take the negative charge, electric field lines will always converge to this point. So converge ಆಗ್ತದೆ. Correct? So if I consider any Gaussian surface over this, ಇದಕ್ಕೊಂದು ಯಾವುದೋ Gaussian surface ತಗೊಂಡಿ ಅಂತಂದ್ರೆ ಒಂದು ಸರ್ಫೇಸ್ ಇಂದ ಹೊರಗಡೆ ಹೋಗ್ತದೆ ಅಥವಾ ಸರ್ಫೇಸ್ ಇಂದ ಒಳಗಡೆ ಬರ್ತದೆ. This is called as influx and we call this one as outflux. Influx and outflux ಅಂತ ಕರಿತೀವಿ. That's why it is called as a flux. Right? So anything that is quantity, if I consider this the electric field coming out of the a closed surface. So closed surface that is going to give us a Q divided by epsilon naught by Rho. But how do we define the magnetic flux out of this? See, if I take the closed surface B dot ds, B dot ds. Generally, in case of this one, what we do? So we take that del dot E. So del dot E in case of differential form, del dot E is equal to rho divided by epsilon naught by Rho. Right? Del dot E is equal to rho divided by epsilon naught. So del dot is nothing but a divergence. So divergence is nothing but you are going to calculate the flux of that. Therefore, if I take the closed integral over B dot ds, ಯಾವುದೋ ಒಂದು ಕ್ಲೋಸ್ ಸರ್ಫೇಸ್ ದಿಂದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಎಷ್ಟು ಹೊರಗೆ ಬರ್ತದೆ ಅಂತ ನೋಡಕ್ ಹೋದ್ರೆ ಅಲ್ಲಿ ಹೊರಗೆ ಬರಂಗಿಲ್ರಿ ಅದೇನಾಗ್ತೈತಿ, ಎಲ್ಲಿ ಎಂಟರ್ ಆಗ್ತೈತಿ, ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತೈತಿ ಅಲ್ಲಿನ ಹೋಗಿ ಮತ್ತೆ ಹೋಗಿ ಎಕ್ಸಿಟ್ ಆಗಿಬಿಡ್ತೈತಿ, ಮೀನ್ಸ್ ಎಂಡ್ ಆಗಿಬಿಡ್ತೈತಿ. ಸೊ ಅದು ಸ್ಟಾರ್ಟ್ ಆಗೋದು ಒಂದ ಪಾಯಿಂಟ್ ಸ್ಟಾರ್ಟ್ ಆಗೋದು ಮತ್ತೆ ಎಂಡ್ ಆಗೋದು ವಿದಿನ್ ದ ಸಿಸ್ಟಮ್ದಾಗ ಇರ್ತೈತಿ. ಬಟ್ ಇಲ್ಲಿ ಹಂಗಲ್ಲ, ಒಂದು ಕಡೆ ಚಾಲೂ ಆಯ್ತು ಅಂತಂದ್ರೆ ಇದು ಅಪ್ ಟು ಇನ್ಫಿನಿಟಿ ಪಾಯಿಂಟ್ಸ್ ತನಕ ಈ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ಗಳು ಡೈವರ್ಸ್ ಆಗ್ತಿರ್ತಾವೆ. Infinity points strength ಕಡಿಮೆ ಆಗ್ತದೆ, but they are going to getting out of a single point or they are getting into the single point. But here ಹಂಗಲ್ಲ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟಾರ್ಟ್ ಆಗೋದು ಅದು within the system, ಎಂಡ್ ಆಗೋದು within the system. Therefore, magnetic flux coming out of the field or any system is defined as zero. Therefore, ಇದನ್ನು ನಾವೇನಂತ ಬರಿತೀವಿ, del dot B is equal to 0 ಅಂತ ಬರಿತೀವಿ. Del dot B is equal to 0. So this is nothing but a Gauss law of magnetic field. Gauss law of magnetic field. Gauss law of magnetic field. And similarly, as there is a divergence is equal to 0 ಅಂತ ಬಂತು, if you take any divergence is equal to 0 ಅಂತ ಬರ್ತೀವಿ ಅಂದ್ರೆ we are going to define there is electric field ಒಳಗೆ ಹೆಂಗ್ ಬರಿತೀವಿ, static electric field ಒಳಗೆ del cross E ಇತ್ತು ಅಂತಂದ್ರೆ for this is equal to 0 ಬಂದಿತ್ತಂದ್ರೆ for electric field there exists a potential ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತಿದ್ವಿ. ಯಾವ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫೈನ್ ಮಾಡ್ತಿದ್ವಿ ಇಲ್ಲಿ? we used to write that potential as minus del V ಅಂತ ಬರಿತಿದ್ವಿ, but as in case of this, as the divergence of del dot B is equal to 0 ಅಂತ ಬರೋದಂದ್ರೆ this exists for this field B ಗೆ ಒಂದು ಇನ್ನೊಂದು ವೆಕ್ಟರ್ ಫೀಲ್ಡ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತದೆ. ಇಲ್ಲಿ ವೆಕ್ಟರ್ ಫೀಲ್ಡ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತದೆ, that is given by del cross of A. ಯಾವುದೋ ಸಿಸ್ಟಮ್ ಆದ್ರೂ ಅದಕ್ಕೊಂದು ಡೈವರ್ಜೆನ್ಸ್ 0 ಆಗಿತ್ತು ಅಂದ್ರೆ ಅದು ಯಾವುದೋ ಒಂದು ಕ್ವಾಂಟಿಟಿದ ಕರ್ಲ್ಗೆ ಈಕ್ವಲ್ ಆಗಿರ್ತೈತಿ. So this A is defined as magnetic vector potential. This A vector is defined as magnetic vector potential. Magnetic vector potential. So direction of the magnetic vector potential is in the direction of the current always. Parallel or anti-parallel. Remember there we define that one as this E vector is given by magnetic vector potential A is equal to 1/2 times of B vector plus R vector. So if you look at this, see, if a current carrying conductor hingal ಸುತ್ತಲೂ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಲ್ಲೇ ಐತ್ರಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡೈರೆಕ್ಷನ್ ಈ ಪ್ಲೇಸ್ ಒಳಗಡೆ ಆಸ್ ದ ಕರೆಂಟ್ ಹಿಂಗ್ ಅಪೋರ್ಡ್ ಹೊಂಟದಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಇರ್ತೈತಿ ಇಲ್ಲಿ? ಇಟ್ ಈಸ್ into the paper. ಈ ಕಡೆಯಿಂದ ಔಟ್ ಆಫ್ ದ ಪೇಪರ್ ನ ಬರ್ತದೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದು, ರೈಟ್? ದಿಸ್ ಇಸ್ into the paper. As it is going into the paper and let us consider this is the R. Then if you take C, ಇದು ಒಂದು ಈ ಕಡೆ ಹೊಂಟತಿ, then ಇದ್ರ ರೇಡಿಯಸ್ ವೆಕ್ಟರ್ ಈ ಕಡೆ, ಸೊ ಇದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಯಾವ್ದು ಇರ್ತೈತಿ? So let us consider this a magnetic field direction in this direction. So ಹಿಂಗ್ ಹೊಂಟದ magnetic field ಹಿಂಗ್ ಹೊಂಟದ. Then radius r ada. If you take the cross product of these two, what you get the direction of the magnetic moment, sorry, magnetic vector potential. So it will be perpendicular to these two vectors. E vector ku ಮತ್ತು E vector ku perpendicular ಆಗಿ A vector ಆಗುತ್ತೆ. So this is B vector and R vector. Therefore, so this is defined as B cross A is equal to A vector. So direction of the vector potential ನೋಡ್ರಿ ಈ vector potential ಏನು direction ಯಾವ ಕಡೆ ಇದೆ? It is in the direction of current or maybe ನಾವು ಡೈರೆಕ್ಷನ್ ಆರ್ ಅನ್ನು ಈ ಕಡೆ ತಗೊಂಡು ಔಟ್ ಆಫ್ ದ ಪೇಪರ್ ನಾಗ ಬಂತಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹಿಂಗ್ ಬರ್ತೈತಿ ಈ ರೇಡಿಯಸ್ ಹಿಂಗ್ ತಗೊಂಡ್ರೆ ಅವಾಗ ಏನಾಗಿರ್ತೈತಿ ಡೌನ್ವರ್ಡ್ ಇರ್ತೈತಿ ಸೊ ಇಟ್ ಮೇ ಬಿ ಆಂಟಿ ಪ್ಯಾರಲಲ್ ಆರ್ ಪ್ಯಾರಲಲ್ ಟು ದ ಕರೆಂಟ್ direction. Therefore, taken the point that as direction of vector potential is direction of vector potential is vector potential is in the direction of is in the direction of current. So it is as the direction as current in the direction of current maybe it may be parallel or anti-parallel, maybe parallel or anti-parallel. Okay. So therefore, similar actually this magnetic moment na hingo B cross R bariತೀವಿ. If you know the only magnetic field, take down its position vector, then cross product ತೋರಿ divided by 2 ಮಾಡಿದ್ರೆ ನಿಮಗೆ magnetic field potential vector ಬರ್ತದೆ. But even ಇದೇ magnetic vector potential ನ magnetic dipole ಗೂ ಕೂಡ ಡಿಫೈನ್ ಮಾಡಿ. Magnetic dipole ಅಂತ ಇದೆ ಬಾರ್ magnetic dipole ಅಂತ ಕರಿಬಹುದು. Both south pole and north pole they are separated by a certain distance, that is nothing but a dipole. Then this is called as a magnetic dipole. Magnetic dipole. Okay. So magnetic dipole, that vector potential for a magnetic dipole is given by magnetic vector potential due to magnetic dipole. Due to magnetic dipole. Magnetic dipole. That is A vector is equal to A vector is equal to mu naught divided by 4 pi, that is m sin theta divided by r square into phi cap, that is in the direction of phi cap generally. So this is what the magnetic field due to a potential vector potential due to magnetic field. ಈಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಗೆ ನೋಡ್ರಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಗೆ ಅದಕ್ಕೆ ಒಂದು ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ V ಅಂತೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ that is A ಅಂತೆ, that's it. Okay, so it's electric field vector potential vector, so electric field vector, electric field potential, this is magnetic field potential, but this is a scalar here, it's a vector here, remember. Is that clear? So one problem ಅನ್ನು ಇದರ ಬೇಸ್ ಮೇಲೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ನೋಡ್ರಿ. So take down problem, that is the magnetic field corresponding to the vector potential magnetic field corresponding to vector potential vector potential that is A vector is equal to 1 by 2 times of f cross r plus 10 by r cube times of r vector. So where f is a constant vector and put on. So where f vector is constant vector, is a constant vector. Now, any constant vector, remember, ಇದಕ್ಕೆ ಏನಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕೇಳತ್ತಾನ ಬಿ ಕೇಳತ್ತಾನ. ಸೊ ಈಗ ನಿಮ್ಗೆ ಎ ಕೊಟ್ಟಾನ ಬಿ ಕೇಳತ್ತಾನ. ವಾಟ್ ಇಸ್ ದ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಬಿ ಅಂಡ್ ಎ? Relation between B and A is
Del
That is
cross
B
A vector.
vector is equal to del cross A vector. Del cross A vector, isn't it? Therefore, ಇದನ್ನ apply ಮಾಡಿದ್ರೆ B calculate ಮಾಡ್ರಿ. Before that, there is another one point that if it is a constant vector ಆಗಿತ್ತಂದ್ರೆ ನೀವು del cross apply ಮಾಡ್ತೀರಿ. Del cross ಇದ್ರ ಮೇಲೆ apply ಮಾಡ್ತೀರಿ. follow ಮಾಡ್ತೀನಿ ತಗೋರಿ. So I need to write, see, B vector is equal to del cross of what is the quantity? So 1 by 2 times of F cross R vector, F cross R, then plus del cross of, that is 10 divided by R cube into R vector, right? Then what exactly this is? So see, for any constant vector, F is a constant vector right here. For any constant vector, for any constant vector, that is del cross A cross, if for example A is a ಒಂದು constant vector ಅಂತ ಅನ್ಕೋರಿ, vector A, okay, vector A, that A del cross A cross R is equal to always 2A ಅಂತ ಬರ್ತದೆ. And similarly, as we have taken this del cross C, this is the cross product, the curl of this result. This is given by 1 by 2 times of what I get from this relation, del cross F cross R, this is going to be 2F vector. Then into plus, what is the del cross of 10 divided by R cube into R vector? What is the del cross of R vector? What is exactly del cross of R vector? Del cross of R vector divided by R cube, the result ಏನು ಬರುತ್ತೆ ಗೊತ್ತಂದ್ರೆ 0 ಬರುತ್ತೆ. ಮಾಡಿ ನೋಡಬೇಕು. ಸೊ ರಿಸಲ್ಟ್ ಬರ್ತೈತಿ, 0 ಬರ್ತದೆ. ಬಿಕಾಸ್ ಇಟ್ಸ್ ಕರ್ಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು, ಆರ್ ಅನ್ನ ಎಕ್ಸ್ ವೈ ಜೆಡ್ ಒಳಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, ಯೂನಿಟ್ ವೆಕ್ಟರ್ ತಗೋಬೇಕು, ಮಾಡ್ಕೋತ ಹೋಗ್ಬೇಕು. ದಟ್ ರಿಸಲ್ಟ್ ಬರ್ತದೆ ಬಿ ಅಂತ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ವೆಕ್ಟರ್ ಬರ್ತೈತಿ. ಓಕೆ, ಇದು ಕ್ರಾಸ್, ಇದು ಡೈವರ್ಜೆನ್ಸ್ ಕರ್ಲ್ ಬೇಸ್ ಮೇಲೆ ಅದ. ನಾ ಇನ್ನೊಂದು ಕೊಡ್ತೀನಿ ತೋರಿ, ಅದನ್ನ ಮಾಡಿ. ಸಿಂಪಲ್ ಅದ ನೋಡಿ, ಇಲ್ಲೊಂದು ಪ್ರಾಬ್ಲಮ್ ಅದ, ಅದನ್ನ ತೋರಿ ಸಿಂಪಲ್ ಅದ ಮಾಡಿ. ದಟ್ ಈಸ್ ಹಿಯರ್ given uniform magnetic field is given uniform magnetic field is B equal to B naught K, B equal to B naught K cap. Okay, a possible choice of magnetic vector potential is possible choice of magnetic vector potential is magnetic vector potential A is, ಈಗಿನ ಆಪ್ಷನ್ ಒಳಗಡೆ ಯಾವ್ದನ್ನ ಎ ಅಂತ ಚೂಸ್ ಮಾಡ್ತೀರಿ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಗೆಟ್ ದ ಬಿ ಅಂತ ಕೇಳೋಣ. ಸೊ ಫಸ್ಟ್ ಆಪ್ಷನ್ ಇಸ್ ಬಿ ನಾಟ್ ವೈ ಐ ಕ್ಯಾಪ್, ದೆನ್ ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ minus b naught y j cap, then C option b naught x j cap plus y I cap, then D option b naught x I cap plus y j cap. So check ಮಾಡಿದ್ರೆ ಆನ್ಸರ್ ಹೇಳ್ತಾರೆ ನನಗೆ. ಓಕೆ, ಡಿಡ್ ಯು ಗೆಟ್ ದಿಸ್? ಬಂತ್ರೆ ಆನ್ಸರ್, ಏನು ಬರ್ತದೆ ಆನ್ಸರ್? ವಿಚ್ ಇಸ್ ದ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಹಿಯರ್? ಏನ್ ಚೆಕ್ ಮಾಡಬೇಕು ನೀವು? ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡೆಲ್ ಕ್ರಾಸ್ ಎ ಚೆಕ್ ಮಾಡಬೇಕು. ಯಾವ ಎ ಅನ್ನು ಹಾಕಿದ್ರೆ ನಿಮ್ಗೆ ಬಿ ಈಕ್ವಲ್ ಟು ಬಿ ನಾಟ್ ಕೆ ಕ್ಯಾಪ್ ಬರ್ತೈತಿ. ಚೆಕ್ ಮಾಡ್ರಿ, ಕರ್ಲ್ ತಗೋಬೇಕು, ಕರ್ಲ್ ತಗೊಂಡು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕು. ಹೌದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಡೆಲ್ ಕ್ರಾಸ್, ಡೆಲ್ ಅನ್ನು ಹೆಂಗೆ ತಗೋತ್ರಿ? ದಟ್ ಇಸ್ ಬಿ ವೆಕ್ಟರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ದಟ್ ವಿಲ್ ಬಿ del cross means I j k cap, then dou by dou x, dou by dou y, then dou by dou z. Then what is the I component? ಯಾವ್ದು ತಗೊಂಡ್ರೆ ನಿಮಗೆ ಲಾಸ್ಟ್ ಕೆ ಬರ್ತೈತಿ? ಕೆ ಕಂಪೋನೆಂಟ್ ಬರಬೇಕಾದ್ರೆ ಯಾವ ಕಂಪೋನೆಂಟ್ ನ ಇಡಬೇಕಿಲ್ಲ. ಎಲ್ಲ ಆಪ್ಷನ್ ಚೆಕ್ ಮಾಡ್ಬೇಕು. ಎಲ್ಲ ಆಪ್ಷನ್ ಚೆಕ್ ಮಾಡಿದಾಗ ಆನ್ಸರ್ ಯಾವ್ದು ಬರ್ತದೆ ಗೊತ್ತ್ರಿ? ಲೆಟ್ ಅಸ್ ಪುಟ್ ದಿಸ್ ಬಿ ನಾಟ್ ವೈ ಹಾಕ್ರಿ. ಬಿ ನಾಟ್ ವೈ ಹಾಕಿ ನೋಡ್ರಿ ಏನ್ ಬರ್ತದ ಆನ್ಸರ್? If you put a b naught y, first one b naught y, I cap direction agade. So if I take this b naught y 0 0, then what is the result of b? That it will b is equal to Is that going to plus B naught K?
No, sir.
No. Answer is Brangla. So if you take the only I component at ಆಗ್ತದೆ. I component ಆಗುತ್ತೆ ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ. If I take I component ತಗೊಂಡೆ ಅಂತಂದ್ರೆ ಏನ್ ಬರ್ತೈತಿ ಇಲ್ಲಿ? B equal to I component ತಗೊಂಡ್ರೆ I is going to be 0 0 complete 0 ಆಯ್ತು. Minus J component ತಗೋರಿ J component ತಗೊಂಡ್ರೆ 0 plus K component ತಗೋರಿ K component ತಗೊಂಡ್ರೆ it is going to be only B naught. So this is B vector is equal to B naught K cap ಬರ್ತೈತಿ. ಅದಲ್ಲ ಆಪ್ಷನ್ ಬರ್ತದೆ. It should be minus, sorry, the minus sign ಬರ್ತೈತಿ. So it is going to be minus B naught K ಬರ್ತೈತಿ. Because ಇಲ್ಲಿ ಇದನ್ನ K cap ತಗೊಂಡಾಗ ಇದನ್ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ 0 ಆಗ್ತೈತಿ. ಇದನ್ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದಾಗ minus B naught ಬರ್ತೈತಿ. So K K minus B naught K ಬರ್ತೈತಿ. Minus B naught K ಅಂದ್ರೆ ಆಪ್ಷನ್ ಎ ಆಗಂಗಿಲ್ಲ. ಬಟ್ ಬಿ ತಗೋರಿ ಅಲ್ಲಿ ಮೈನಸ್ ತಗೊಂಡ್ರೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಮೈನಸ್ ತಗೊಂಡ್ರೆ ಇದು ಪ್ಲಸ್ ಬರ್ತೈತಿ. ಆಪ್ಷನ್ ಬಿ ಇಸ್ ಕರೆಕ್ಟ್. ಕರೆಕ್ಟಾ? Is it correct? Okay, next is magnetic boundary conditions.
Sir, B naught minus B naught y J cap is sir.
Oh, sorry. ಓಕೆ ಇದು ಜೆ ಕ್ಯಾಪ್ದಾಗ ಹಾಕ್ಬೇಕಲ್ಲ ಜೆ ಕ್ಯಾಪ್ದಾಗ ಹಾಕಿದ್ರೆ ಕರೆಕ್ಟ್ ಬರ್ತದೆ ನೋಡ್ರಿ ಚೆಕ್ ಮಾಡ್ರಿ ಸರ್ ಐದಾಗ ಹಾಕಿದಾಗ ಬರಲಿಲ್ಲ ಮೈನಸ್ ಬಿ ನಾಟ್ ಕೆ ಬರ್ತದೆ ನಮ್ದು ಹೌದಾ ಇದಾಗಂಗಿಲ್ಲ ಅಂದ್ರೆ ಜೆದಾಗ ಹಾಕಿದ್ರೆ ಬರ್ತದೆ ನೋಡ್ರಿ ಹೌದಾ ದಿಸ್ ಇಸ್ ಆಪ್ಷನ್ ಬಿ ಐ ಇಲ್ಲ ಜೆ ಇಲ್ಲ ಐ ಅದು ಯಾವುದೋ ಆಪ್ಷನ್ ಬರಂಗಿಲ್ಲ ಈಗ ನಾವು ಕೊಟ್ಟಿದ್ದ ಪ್ರಕಾರ ಯಾವುದೋ ಆಪ್ಷನ್ ಬರಲ್ಲ ಪುಟ್ ದಿಸ್ ಒನ್ ಐ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಅದು ಐ ಇದನ್ನ ಅದಾಡ್ರಿ ಐನ ಅದ ನಾನು ಜೆ ಬರ್ತೀನಿ ಇಟ್ ಇಸ್ ಐ ಈಗ ಬರ್ತದೆ ಆನ್ಸರ್ ಜೆದಾಗಿಟ್ಟ ಆನ್ಸರ್ ಬರಲ್ಲ if you put this one in terms of j you are going to get 0 again ನೀವೇ ಅಂತೂ ಯಾವ ಬರಂಗಿಲ್ಲ ಸೊ ಇದು ಆಯ್ ಆಗುತ್ತೆ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಆಯ್ ಕರೆಕ್ಟ್ ನಾ ಈಗ ಆಯ್ದಾಗ ಆಯ್ಕೆ ನೋಡಿ ಕರೆಕ್ಟ್ ಬರ್ತದೆ ಆನ್ಸರ್ ಇದಕ್ಕೆ yes next is magnetic boundary conditions your boundary conditions how do you apply boundary condition for this remember it is same like thing like if you consider this the interface from one medium to another medium that is mu1 mu0 mu1 and mu2 then there is this is the normal if anything enters this magnetic field enters with an angle theta 1 with respect to normal then it exits from theta 2 with respect to normal then let us consider this is b1 and this is b2 therefore same here also boundary conditions our first boundary condition is so this the perpendicular component of the magnetic field below sorry above minus below be 0 exactly electric field the opposite to ಇಲ್ಲಿ above minus magnetic field below is treated as 0 means it is continuous perpendicular component of the magnetic field ಏನಿರ್ತಾವ continuous ಆಗಿರ್ತಾವ but parallel components are not continuous therefore we define this one as b parallel above minus b parallel below is equal to mu naught k ಅಂತ ಬರೀತೀವಿ mu naught k where k is called as what is this k is defined as surface charge density or volume charge density volume current density this is k is volume current density volume current density these are discontinuous remember these are discontinuous
So surface.
J is defined as J is volume and K is surface. Correct. Now with the magnetic field lines of different breathing. J is volume, K is surface. Here K J sigma mu sigma epsilon number mu not sigma over type. Therefore it is going to be what volume? It is surface. So this is surface current density. Surface current density where J is defined as volume current density. Okay, correct. Then similarly we define that one as uh, even H. So this is magnetic fields boundary conditions. Okay. Then there is see, do you know the relation between magnetic field and magnetic intensity? Of magnetic field strength to magnetic induction. Here B is defined as magnetic induction, right? Magnetic induction. Generally, actually, no magnetic field ಅಂತ ಕರಿತೀವಿ. But H is defined as magnetic field strength or magnetic intensity. Magnetic intensity. Okay. So, what is the relation between B and H generally? B and H is different. B is equal to mu into H. Remember, it's important relation. Similarly, ಇಲ್ಲಿ ಯಾವಾಗ ನಾವು ಮ್ಯಾಗ್ನೆಟೈಸ್ ಮಾಡಕ್ಕೆ ಹೋಗಿರಲಿಲ್ಲ ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್ ಬಗ್ಗೆ ಹೇಳಿ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಬಿ ಮತ್ತು ಎಂ ನೋಡ್ ರಿಲೇಷನ್ ಹೇಳಿವಿ ಬಿ ಎಂ ಅಂಡ್ ಎಚ್ ಅಂತೆ right in the same way as you are going to magnetize the material because of their dipoles are going to orient along the applied what is that magnetic field applied magnetic field on this okay applied magnetic field apply ಮಾಡಿದಾಗ ಹೆಚ್ಚಿನ apply ಮಾಡ್ತೀರಿ there is induced magnetic field B inside this B ಅನ್ನೋದು induced magnetic field induce ಆಗ್ತೈತೆ ಆವಾಗ here also there are two charges will appear two currents will appear one is bound surface current density another one is bound volume current density so one is bound current density bound surface current density surface current current density and second one is volume bound volume current density bound volume current density volume current density as in case of polarization we have seen that there are two types of charges will appear on the surface of the dielectric that is one is surface bound charge and the other one is volume bound charge here bound surface current density and bound current volume current density therefore generally we define this surface density as K then this one as J. This is KB is nothing but bound surface current density. JB is nothing but bound volume current density. Therefore, generally this KB is given by KB is a vector quantity, then that is given by magnetization into its captain n cap. The in case of JB is defined as JB vector is equal to del cross M. Do you know what is the relation? How do we represent that one in terms of polarization? Polarization ಇದಕ್ಕೆ ಪ್ಯಾರಲ್ ಆಗಿರೋದು ಯಾವ್ದ್ರಿ ಸಿಗ್ಮಾ ಸಿಗ್ಮಾ ಬೌಂಡ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ ಅಂದ್ರೆ ಜೆ ಬಿ ಅಂತಂದಲ್ಲಿ ರೋ ಬಿ correct volume charge density so how do we define there it is defined as p vector dot n cap isn't it there is that p vector dot n cap and the another one is that del cross p or del dot p there ಒಳಗೆ ಹೆಂಗ್ ಬರೀತೀರಿ ಅದನ್ನ
Minus of
minus
del
of
dot
del
P.
dot p yes so that is given by there minus of del dot p so ಎರಡು ಒಂದ ನೋಡ್ರಿ so similarities ಅದಾವ ಒಂದಕ್ಕೊಂದು similarity ಇದೆ electrostatics ಗೊತ್ತಿದ್ರೆ magnetostatics ಗೊತ್ತಿದ್ದಂಗೆ so here it is called as surface current density volume current density here it is surface charges charge density volume charge density is that clear on then what is the relation between bm and h so what is the relation between bm and h do you know anyone already ಇದನ್ನ ಹೇಳಿನಿ b and h no relation B and F natural relation entry. That is, see, we generally write B is equal to, we write that B is equal to mu H, right? This B is equal to mu can be written as mu R into mu naught into H. This mu naught is mu R is given by, so this B is equal to, that is mu R, mu naught into H, that is mu R. Mu R is nothing but 1 plus xi, then therefore it is mu naught H plus mu naught mu R mu naught xi into H anta baradu. What is this? So do you know what do you mean this? Here mu naught H into mu naught xi into H, that is equal to magnetic field. So what is this? This mu naught xi into H, is that M? M with mu naught H, that is equal to B. Is it clear? ಇಲ್ಲಿ mu naught xi into H ಗೆ ನಾವು polarization ಅಂತ ಕರಿತೀವಿ, ಇಲ್ಲಿ magnetization ಅಂತ ಕರಿತೀವಿ. That is the relation. Done with this? Next is electrodynamics. Now, till now we have discussed about electrostatic parts and magnetostatic parts. So we have completed electrostatic part, then magnetostatic part. Okay. Now let us study about electrodynamics. It is going to include both the flow of charges or variation of electric field and magnetic field up to time. That is dynamical parts. Therefore, now let us start with electrodynamical parts. First, electrodynamics at ಬಂದ ಕೂಡಲೇ first like ಬರ್ತದೆ ಏನ್ರಿ? That is nothing but EMF or Faraday's law. First one is, here we are going to discuss about the Faraday's law. What do you mean by Faraday's law? It is a ಯಾವುದೇ ಬೇಕಾದ quantity the flux ಇರಲಿ. Generally, in case when it comes to, moreover in case of electrodynamics, we are going to connect between electric field and magnetic field. This gives the relation between magnetic field B and electric field. ಎರಡು relation ಸಿಗ್ತದೆ ನನಗೆ. ಏನಿದು mainly? See, here, due to the change in the flux of a current carrying conductor that is producing a magnetic field, it is going to produce an induced EMF in the circuit that is provided by Faraday's law. What exactly Faraday's law tells? Faraday's law. Faraday's law of electromagnetic induction ಅಂತ ಕರಿತೀವಿ. That is EMF, EMI or electromagnetic induction. How to define this induced EMF in the circuit? This induced EMF is given by induced EMF. EMF E is equal to the rate that is rate of change of flux. Induced EMF is directly proportional to the rate of change of the flux, and it opposes according to the Lenz's law, isn't it? There are two laws are there. One is this negative sign indicates the direction of the current. So negative sign indicates direction of the current, and moreover it opposes the production or flux. EMF ಅನ್ನು provide means create ಮಾಡಬೇಕಾದ್ರೆ oppose ಮಾಡ್ತೈತಿ, right? Therefore that is defined as it is proportional to the field flux, change in the flux, but it opposes the production of that one. That is, sign indicates it's a negative direction or direction of current. That is the first law. ಇದಾಗ ಎರಡು law ಒಂಥರ first law. Second one ಇನ್ನೊಂದು ಯಾವುದು? That EMF is directly proportional to d phi by dt. Induced EMF ಏನದ? That is nothing but rate of change, change in the flux that produces the induced EMF. But ಅದೇನದು induced EMF always ಏನಿರ್ತೈತಿ, ಅವರ flux ಏನು change ಆಗುತ್ತೆ ಅದು induced EMF ಅನ್ನು induce ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ಅಪೋಸ್ ಮಾಡ್ತದೆ in negative direction. That is defined as a negative sign ಅಂತ ಬರಿತೀವಿ. Actually ಅದಕ್ಕೆ Lenz's law ಅಂತ ಕರಿತೀವಿ. What we call is that Lenz's law. It produces the induction of it opposes the induction of EMF. So that is what is Faraday's law. That is generally we write that is EMF induced in the circuit. EMF induced in the circuit is equal to minus d phi by dt. Then how do they calculate this phi? What do you mean by this phi? Phi is defined as flux. It's a flux. Generally, we call that one as magnetic flux. Magnetic flux. What do you mean by this magnetic flux? If a, so for example, let us take this from the other rectangular with another what you call ಒಂದು coil ಇದೆ. ಈ coil ಒಳಗಡೆ magnetic field ಗಳು ಪಾಸ್ ಆಗತ್ತವೆ. Okay, magnetic field ಗಳು ಹಿಂಗೆ ಪಾಸ್ ಆಗತ್ತವೆ. So if this normal to this plane ಏನು wire plane ಅದಲ್ಲ ಈ plane ಅದ normal ಏನದ ಇದು perpendicularly ಈ direction ಆಗದ ಅನ್ಕೊಳ್ಳಿ. Let us consider this is in this direction ಈ ಕಡೆ ಅದ. Means always plane ಒಂದು ಯಾವುದೋ ಒಂದು plane ತಗೊಂಡ್ರಿ ಈ ಪ್ಲೇನ್ ಡೈರೆಕ್ಷನ್ ಯಾವ್ದು ಹೇಳ್ತಿರ್ತೈತ್ರಿ ಇದಕ್ಕಿರೋ ನಾರ್ಮಲ್ ಹೇಳ್ತಿರ್ತೈತಿ ಈಗ ನಾ ಅಪ್ಲೈಡ್ ಫೀಲ್ಡ್ ಯಾವ ಕಡೆ ಅದ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದಿಸ್ ಅಪ್ಲೈಡ್ ಫೀಲ್ಡ್ ಆರ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್ ಯಾವುದೋ ಒಂದು ರ್ಯಾಂಡಮ್ ಡೈರೆಕ್ಷನ್ ಈ ಕಡೆ ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ಸ್ ಅದಾವ ಇದು ಓರಿಯೆಂಟ್ ಆಗ್ಯದ ಈ ತರ ಅದು ಇಟ್ಸ್ ಕಾಯಿಲ್ if it makes an angle theta here then how to calculate the magnetic flux maximum ಯಾವಾಗ ಪಾಸ್ ಆಗ್ತೈತಿ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಇದು ಕಾಯಿಲ್ ಏನದ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರ್ಬೇಕು ಇವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ಗಳು ಏನು ಪಾಸ್ ಆಗತ್ತವ ಇದಕ್ಕೆ ದಿಸ್ ಕಾಯಿಲ್ ಏನಾಗಿರ್ಬೇಕು ಎಕ್ಸಾಕ್ಟ್ಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ನಿಂತಿರ್ಬೇಕು ಎಕ್ಸಾಕ್ಟ್ಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರ್ಬೇಕು ಸೊ ದೀಸ್ ಟು ಆರ್ ಇನ್ ದ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಒಳಗಿತ್ತು ಅಂದ್ರೆ ಫ್ಲಕ್ಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಕಾಲ್ಡ್ ಆಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ದೆನ್ ಅದ ಅಕಸ್ಮಾತ್ ಇದ ಫೀಲ್ಡ್ಗೆ ಈ ಅಪ್ಲೈಡ್ ಫೀಲ್ಡ್ಗೆ ಅದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿತ್ತು ಅಂತ ನಿಮ್ಗೆ ಏನ್ ಸಿಗ್ತೈತಿ ಫ್ಲಕ್ಸ್ ಸಿಗಂಗಿಲ್ಲ ಅಂದ್ರೆ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ವಿಚ್ ಆರ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಕ್ರಾಸ್ ಸೆಕ್ಷನಲ್ ಏರಿಯಾ ಆಫ್ ದಟ್ ಕಾಯಿಲ್ ಸೊ ನೀವು ಏನಾದ್ರು ಈ ತರ ಇಟ್ಟಿದ್ರಿ ಈ ತರ ಕಾಯಿಲ್ ಇಟ್ಟಿದ್ರಿ ಆ ಕಾಯಿಲ್ ಇಲ್ಲಿ ಒಳಗಡೆ ಈ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಥ್ರೂ ಏನಾಗಲ್ಲ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ಸ್ ಗಳು ಪಾಸ್ ಆಗಂಗಿಲ್ಲ therefore flux here is equal to 0 therefore magnetic flux is generally defined as that is phi is equal to that is b dot a so if the unit normal vector to the area where a is defined as area where b is defined as a field and field lines field so the particular cross section through magnetic field pass agatiತ್ತು ಅಂದ್ರೆ ಅಲ್ಲಿ flux create ಆಗ್ತದೆ so I can rewrite that phi is equal to ba cos of theta depending on the theta we are going to define magnetic field flux which is flowing out of that cross section area let us consider if the area is constant for example ಯಾವುದೋ ಒಂದು coil cross section area constant ಅದ so case let us consider case a the area is constant area A is constant ಅದ ಅನ್ಕೊಳ್ಳಿ ಈಗ ಒಂದು rectangular coil ತಗೋರಿ rectangular coil ತಗೋರಿ ಈ ತರ let us take this rectangular coil here then ಇದನ್ನ ಏನು ಮಾಡ್ರಿ ಒಂದು ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ so let us apply here strong ನಾರ್ತ್ ಪೋಲ್ ಅದ ಅನ್ಕೋರಿ ಇಲ್ಲಿ ಸೌತ್ ಪೋಲ್ ಅದ ಅನ್ಕೋರಿ ಇದ್ರ ಥ್ರೂ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಗಳು ಪಾಸ್ ಆಗತ್ತವೆ ಕರೆಕ್ಟಾ ಇದು ರೊಟೇಷನ್ ಆಗತ್ತದ if it is rotating with an angular velocity omega magnetic flux flowing out of this one is given by that is phi or ಈ ಕಾಯಿಲ್ ಒಳಗಡೆ ಎಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಸಾರಿ EMF ಇಂಡ್ಯೂಸ್ ಆಗಿದೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಫಸ್ಟ್ ಲೆಟ್ us consider it calculate this b dot a so I'll define that as ba cos theta what is theta theta ಅನ್ನೋದು ಏನೋ ಇದು rotate ಆಗತ್ತದ every second is rotate ಆಗತ್ತದ therefore theta change ಆಗುತ್ತ ಹೋಗ್ತದೆ therefore this theta is changing with respect to time then we define that rate of change of the theta is defined as omega so I can redefine that one as theta is equal to omega into t by integrating it therefore I will replace this one as ba cos of omega t that is the flux so how do you calculate the magnetic induction that is EMF induced in this coil due to the rotation of this coil in the uniform magnetic field that is EMF is equal to minus d phi by dt therefore EMF is equal to minus d by dt of that is b into a into cos of omega t and if you differentiate what we get here that is equal to from this relation I can redefine that one as EMF is equal to minus b ಮತ್ತು a constant ಅಂತ ತಗೊಂಡಿದ್ರೆ cos of omega t integrate differentiate ಮಾಡಿದ್ರೆ ಏನು ಬರ್ತೈತಿ plus times of sin of omega t into omega ಬರ್ತೈತಿ therefore I can redefine that one as omega is equal to so EMF is equal to omega b into a into sin of omega t therefore from this EMF is equal to I will redefine this one as EMF naught that is sin of omega t from this you can get that the EMF induced in the coil due to the rotation of the coil in the uniform magnetic field is always a sinusoidal sinusoidal EMF. As EMF is sinusoidal, automatically current is also sinusoidal. Therefore, all these quantities, EMF, current, all are sinusoidal. Therefore, this part of the current is defined as AC. So this is alternating current. Alternating current is produced by a constant rectangular coil which is rotated in the uniform magnetic field to produce a EMF due to the change in the magnetic flux with respect to time. That is defined as induced EMF or induced sinusoidal EMF. Then what if this area is constant? What if this area is not constant? When area is variable. Second case is when area is variable. If area A is variable means change ಆಗ್ತಿತ್ತಂದ್ರೆ variable. ಯಾವ ತರ sir? Let us consider there is a magnetic field. The magnetic field ತಗೊಂಡು. So magnetic field ಯಾರನ್ನು ಒಳಗೆ ಹೊಂಟದ್ದು. This is into the plane. So this is a magnetic field into the plane which is perpendicular to the paper. Paper magnetic field ಅನ್ನೋದು perpendicular ಇದೆ. Okay. ಈ ತರ ಒಂದು ಕೇಸ್ ತಗೋರಿ. Okay. Then ಇಲ್ಲೊಂದು ಏನು ಮಾಡ್ರಿ ಒಂದು ಕಾಯಿಲ್ ತಗೋರಿ. Let us consider a coil. So ಈ ತರ ಒಂದು rectangular coil ತಗೋರಿ. ಈ rectangular coil ಅನ್ನು ಏನು ಮಾಡ್ರಿ slowly ಇದರೊಳಗಡೆ ಮೂವ್ಮೆಂಟ್ ಮಾಡ್ರಿ with velocity v. ಇದರೊಳಗಡೆ ಒಂದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿ ಒಂದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಹಾಕೊಂಡು ಓಕೆ ಸೊ ಲೆಟ್ ಅಸ್ ಅಪ್ಲೈ ಹಿಯರ್ ಒಂದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಮೇಲೆ ಇಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇತ್ತು ಇದು ಫ್ಲೋ ಆಗತ್ತಿತ್ತು ಅಲ್ಲಿ ಇ ಎಮ್ ಎಫ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗತ್ತೆ ಕೊಟ್ಟು ಕಾಯಿಲ್ ಒಳಗಡೆ ಆಟೋಮೆಟಿಕ್ಲಿ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗತ್ತೈತಿ ಸೊ ಹಿಯರ್ ಐ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ವಾಟ್ ಇಸ್ ದ ಕರೆಂಟ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಇನ್ ದಿಸ್ ಕಾಯಿಲ್ ಮೇನ್ಲಿ ಇಲ್ಲಿ ಏನಾಗತ್ತದ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಇಟ್ಸ್ ಲೆಂತ್ ಇಸ್ ಎಲ್ ನೋಡ್ರಿ ಇನಿಷಿಯಲಿ ಟೈಮ್ ಟಿ ಈಸ್ ಇಕ್ವಲ್ ಟು 0 ಇದ್ರ ಲೆಂತ್ ಏನೋ ಎಂಟರ್ ಆಗಿಲ್ಲ ಇಲ್ಲಿ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಏನದ ಓನ್ಲಿ ದಿಸ್ ಪಾರ್ಟ್ ಅಷ್ಟೇ ಸೊ ಇನಿಷಿಯಲಿ ದಿಸ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಇಸ್ ಓನ್ಲಿ ದಿಸ್ ಪಾರ್ಟ್ ಇದ್ರಾಗ ಈ ಏರಿಯಾ ಏನದ ಅದು ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪಾಸ್ ಆಗತ್ತದ ದಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ ಅಸ್ ಅ ಫ್ಲಕ್ಸ್ ಪಾರ್ಟ್ ಇಷ್ಟ ಏರಿಯಾ ಪಾಸ್ ಆಗತೈತಿ ಕರೆಕ್ಟಾ ಸೊ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದಿಸ್ ಇಸ್ ಹಿಯರ್ ಇಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹಿಯರ್ ಇಸ್ ಆಲ್ಸೋ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಓಕೆ ದೆನ್ ಇದು ಸ್ಲೋಲಿ ಇದ್ರ ಎಂಟರ್ ಆಗತ್ತದ ಥೀಟಾ ಇಸ್ ಆಸ್ ಥೀಟಾ ಇಸ್ ಇಕ್ವಲ್ ಟು 0 ತಗೋರಿ ಥೀಟಾ 0 ತಗೋರಿ ಯಾಕಂದ್ರೆ ಅದ್ರೊಳಗಡೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಪ್ಯಾರಲಲ್ ಆಗಿ ಹೊಂಟದ therefore theta is equal to 0 or 180 ತೋರ್ ನಡೀತೈತಿ ಏನ್ ಬೇಕಾ ತೋರ್ ನಡೀತೈತಿ 0 ನಮ್ದು so 1 ಆಗ್ತೈತಿ ಇವತ್ತು EMF induced EMF is equal to defined as B into dA by dt now because flux is going to be BA flux is equal to BA and theta is equal to 180 ಆಗಲಿ ಅಥವಾ 0 ಆಗಲಿ ನನಗೆ ಮೈನಸ್ ಅರ ಪ್ಲಸ್ ಬರ್ತೈತಿ ಎನಿವೇ EMF is equal to rate of change of the magnetic flux therefore mod ಹಾಕಿದೀವಿ ಅಂತಂದ್ರೆ ಅದನ್ನ ಪಾಸಿಟಿವ್ಲಿ ಬರೀತೀವಿ this area is changing ಯಾಕಂದ್ರೆ ಟೈಮ್ ಹೋದಂಗೆ ಇದು ಒಳಗೆ ಎಂಟರ್ ಆಯ್ತು ಅಂತ ಅನ್ಕೋರಿ ಆಫ್ಟರ್ ಸರ್ಟನ್ ಟೈಮ್ ಇದ ಕಾಯಿಲ್ ಏನಾಗ್ತೈತಿ ಒಳಗೆ ಈ ತರ ಎಂಟರ್ ಆಗ್ತೈತಿ so let us consider this it enters after certain time so what is the cross section area now the cross section area ಪೂರ ಕೌಂಟ್ ಆಗ್ತೈತಿ ಈಗ ಹೌದಿಲ್ಲ ಅಲ್ಲಿ EMF ಅಲ್ಲಿ ಟೋಟಲ್ EMF ಇಲ್ಲಿ EMF ಬೇರೆ ಇಲ್ಲಿ EMF ಬೇರೆ ಇಲ್ಲಿ EMF ಸ್ವಲ್ಪ ಇರ್ತೈತಿ ಇಲ್ಲಿ ಇನಿಷಿಯಲ್ ಇದು ಫೈನಲ್ therefore EMF ಚೇಂಜ್ ಆಗತ್ತದ therefore if I redefine that as this is moving with a velocity v then length area ಅದ length every time change ಆಗತ್ತದ constant velocity move ಆಗತ್ತದ therefore how to define the area of the rectangular coil area of the cubical coil ಅಥವಾ rectangular coil ಏನಂತ ಬರಿತೀವಿ that is L square that is rate of dA by dt ಅಂತ ತಗೊಂಡ್ರೆ ಒಂದು ಸೈಡ್ ಲೆಂತ್ ಫಿಕ್ಸ್ ರೀ ಇನ್ನೊಂದು ಸೈಡ್ ಲೆಂತ್ ಇದೇನದ ಚೇಂಜ್ ಆಗತ್ತದ right this length is fixed this length is changing I will call this one as or rectangular coil ತಗೊಂಡ್ರೆ ಇದನ್ನ ಲೆಂತ್ ಒಂದು ಬೇರೆ ತಗೊಳ್ಳಿ let us call this is length is b ಅಂತ ತಗೋತೀವಿ small b breadth is length therefore I will define that area as L into b so length ಏನು ತಗೋತೀವಿ area ಏನು ತಗೋತೀವಿ length into b so b constant ಅದ ಇಲ್ಲಿ ಏನಾಗತ್ತದ dl by dt ಆಗ್ತೈತಿ length every time change ಆಗತ್ತದ what is this rate of change of the length with respect to time that is defined as the velocity with which it is moving therefore b into b ಅಂತ ಬರೀತೀವಿ so b is defined as breadth of the coil breadth of the coil therefore what is the induced EMF induced EMF is equal to that is magnetic field b rate of change of this one is given by v into small b so generally ಇದನ್ನ b ಅನ್ನು ನಾವು l ಅಂತ ತಗೊಂಡಿವಿ ಅಂತಂದ್ರೆ EMF is defined as BLV so this is BLV is the EMF induced in the coil EMF it induced ಆಯ್ತು ಅಂದ್ರೆ ಇದ್ರಾಗ EMF ಫ್ಲೋ ಆಯ್ತೈತಿ EMF ಫ್ಲೋ ಆಗತೈತಿ ಅಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಐತಿ ಅಲ್ಲಿಂದ ಕರೆಂಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದ್ರಿ ಸೊ ಕರೆಂಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಇನ್ ದ ಕಾಯಿಲ್ ಇಸ್ ಗಿವನ್ ಬೈ ಒಂದು ಕಾಯಿಲ್ ಅನ್ನು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಪಾಸ್ ಮಾಡೋದ್ರಿಂದ ಅದಕ್ಕೆ ಏರಿಯಾ ಚೇಂಜ್ ಆಗತ್ತಿತ್ತು ಅದು ಅದಕ್ಕೆ EMF ಇಂಡ್ಯೂಸ್ ಆಗತ್ತಿತ್ತು ಅಂದ್ರೆ ಅಲ್ಲಿ ಕರೆಂಟ್ ಕೂಡ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತೈತಿ Therefore, current is given by EMF divided by R. Therefore, EMF is nothing but BLV divided by R. So this is what the current produced in the field. Is that clear that? Then what is the relation between magnetic field and electric field? See, magnetic field and electric field can be calculated by having a constant moving charge in both electric field and magnetic field. A uniform moving moving charge under under both electric field and magnetic field. Under both electric field and magnetic field. Uniformly moving charge and its total net force is equal to zero. Its acceleration is zero. Therefore, what is the magnetic force is given by Fm is equal to a charge into velocity cross B. Then how to define the electric force on the charge particle? That is F is equal to Q into E. Therefore, total net force acting on the charge particle is total net force capital F is equal to Fm magnetic force plus Fe magnetic electric force. Therefore, that is going to if the total net force is equal to zero for uniformly moving charge, then we define this one as that is it is given by Q into V cross B, then into plus Q times of E. Then Q1 and Tagadi I can redefine that. E is equal to minus times of V cross B, minus times of V cross B. So this is what the electric field and magnetic field relation. Okay. Then once if you know the EMF, the electric field ಗೊತ್ತಿತ್ತು, how to calculate the EMF? EMF ಅನ್ನು calculate ಮಾಡೋದು other charge constantly moving or steady current under better. Steady current is nothing but rate of flow of the current is constant. Therefore, steady constantly moving charge ಅಂದಂಗ. Then ಇಲ್ಲಿ ಹೆಂಗ್ define ಮಾಡ್ತೀರಿ? EMF ಅನ್ನು ಹೆಂಗ್ calculate ಮಾಡ್ತೀರಿ? If you know the electric field, how to calculate the EMF? See, what is the relation between EMF and electric field? Relation between EMF and electric field. Relation between EMF and electric field. So EMF is nothing but a voltage potential, right? EMF ಅಂದ್ರೆ potential. Potential na EMF ಈ ತರ ಬರ್ದೇನೆ ಅದ್ರ ಬದಲು ನಾವು V ಅಂತ ಬರಿಬಹುದು, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. E or P ಎರಡು ಒಂದೇ. So do you know what is the relation between electric field and potential? Electric field is equal to negative potential gradient ಅಂತ ಆಲ್ರೆಡಿ ಒಂದ್ಸತಿ ಹೇಳಿದ್ದೀವಿ. Therefore VMF is equal to that is potential is equal to integration over minus terms of E into dr ಅಂತ ಬರಿಬೋದಾ electric field. So from the same relation I can here redefine that one as EMF induced EMF is equal to dV is nothing but integrate ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಇದೇನು ಕೊಡ್ತೈತ್ರಿ induced EMF ಅನ್ನು ಕೊಡ್ತೈತಿ. Induced EMF is equal to minus integration over electric field into dr. If I back substitute that magnetic field, then EMF is equal to minus of minus plus ಆಗ್ತೈತಿ integration over V cross B into dr. So this is the relation between a steady current EMF and magnetic field. Is that clear all? So again magnetic field induce ಆಗ್ತದ. ಏನು EMF ಒಂದು ತನ್ನ ಒಂದು ಕಾಯಿಲ್ ಒಳಗಡೆ ಇಂಡ್ಯೂಸ್ ಆಗ್ತದೆ ಬಿಕಾಸ್ ಆಫ್ ದ ಫ್ಲೋ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಆಗೋದ್ರಿಂದ EMF ಇಂಡ್ಯೂಸ್ ಆಯ್ತು. ಇಂಡ್ಯೂಸ್ ಆಗುವ EMF ಅನ್ನ ಎರಡು ಟೈಪ್ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. ಒಂದು ಸೆಲ್ಫ್ ಇಂಡಕ್ಷನ್, another one is electric field induced within the coil due to the variation of the current in the same coil. ತನ್ನ ಕಾಯಿಲ್ ಒಳಗೆ ತಾನಾಗ ಕರೆಂಟ್ ಚೇಂಜ್ ಆಗೋದ್ರಿಂದ EMF ಒಂದು ಇಂಡ್ಯೂಸ್ ಆಗ್ತೈತಿ, ಹೌದಾ? ದೆನ್ ಒಂದೊಂದು ಬೇರೆ ಒಂದು ಕಾಯಿಲ್ ಒಳಗಡೆ ಏನಾದರೂ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಏನೋ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗೋದ್ರಿಂದ ಅದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇನ್ನೊಂದು ಕಾಯಿಲ್ ಮೇಲೆ ಆಕ್ಟ್ ಆದಾಗ ಅಲ್ಲಿ ಕೂಡ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಂಡ್ಯೂಸ್ ಆಗೋ EMF ಇಂಡ್ಯೂಸ್ ಆಗೋ ಚಾನ್ಸ್ ಇದೆ. ಅದರ ಬೇಸ್ ಮೇಲೆ ದಿಸ್ ಇಂಡಕ್ಷನ್ ಈಸ್ ಕ್ಲಾಸಿಫೈಡ್ ಇಂಟು ಟೂ ಟೈಪ್ಸ್. Inductance, we call that as inductance. So types of inductance. So what are the types of inductance? First one is self-inductance. What do I mean by self-inductance? Self-inductance is nothing but when EMF is induced, when EMF is induced in the coil, in the coil due to in the coil due to variation of current, due to variation of current, variation of current, variation of current in the coil itself, in the coil itself, in the coil itself. So that is defined as induced EMF or self-inductance. Self, so the coil, for example, coil ತಗೋರಿ ಈ coil ಒಳಗಡೆ ಆಲ್ರೆಡಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗತ್ತದ. ಇದ coil the variation of the current ಇಂದ ಏನಾಗತೈತಿ ಇದ್ರೊಳಗ ತಾನ EMF ಅನ್ನು ಇಂಡ್ಯೂಸ್ ಮಾಡ್ಕೊತದ. Therefore induced EMF is given by that is equal to minus d phi by dt, minus d phi by dt, that we know. Then similarly, even we define this phi here. ಏನಲ್ಲ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಬರತೈತಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದ, ಅದು ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಕರೆಂಟ್ ವೇರಿಯೇಷನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದ, ದಟ್ ಈಸ್ ಕರೆಂಟ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದ. ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತೈತಿ ಅಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಆಗ್ತೈತಿ ಅದು, ಕರೆಕ್ಟಾ? ಬಿಕಾಸ್ B is directly proportional to I, B is directly proportional to I is directly, sorry, phi is directly proportional to B. ಇದರಿಂದ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀಬಹುದು phi is directly proportional to I ಅಂತೆ. For self-induced coil, we are going to define that flux is going to be Li. Generally, that L is defined as proportionality constant or proportionality constant, or we call that one as self-induction, coefficient of self-inductance, coefficient of self-inductance, coefficient of self-inductance. Therefore, if I back substitute that phi in that part, that induced EMF in the self-induced coil, that is given by L into di divided by dt. So that is what is the flux. Similarly, do you know energy stored in the self-induced coil? Energy stored in self-induced coil is given by self-induced coil is equal to, that is energy is equal to U is equal to ಏನಂತ ಬರೀತೀವಿ, half L I square. It's actually energy density. It's actually energy density. Generally ನಾವು ಹೆಂಗ್ ಬರೀತೀವಿ, it's a energy density. Energy density. So generally ನಾವು ಎನರ್ಜಿ ಅಷ್ಟ ಬರಿಬೇಕಾದ್ರೆ ಎನರ್ಜಿ E is equal to ಏನಂತ ಬರೀತೀವಿ ಅಲ್ಲಿ, energy E is equal to, that is integration over 1 by 2 times of L I square into d tau ಅಂತ ಬರೀತೀವಿ. What is this d tau? Tau is nothing but volume element. Okay. Then similarly, there is another one concept that is called as mutual inductance. What do you mean by this mutual inductance? Second concept is mutual inductance. So ಒಂದ್ಸತಿ PUC ನೋಡ್ರಿ, definition ಅಷ್ಟ ಕೊಡ್ತೀನಿ ನಾನು. Mutual inductance. So how do we define this mutual inductance? Mutual inductance is nothing but when an EMF is induced in a coil due to the variation of the current in another coil. So here EMF will be induced due to variation of current in another coil. So this is defined as induced EMF. Self-inductance and mutual inductance. Different math. Mutual inductance is the formula direct over again which and moreover, see this we got that induced EMF due to the variable magnetic field is given by, and one of the equation that is EMF is equal to, we know that EMF is equal to minus d phi by dt. Correct? Then so as I told that EMF is nothing but it is a voltage or potential. Electric potential. What is the relation between EMF and electric field? How to define the EMF and electric field? That is EMF is equal to minus integral over E vector dot d r ಅಂತ ಬರೀತೀವಿ. That is E vector dot dr ಅಂತ ಬರೀತೀವಿ. Or also we can write that EMF is equal to minus integration over E dot dl ಬರೀತೀವಿ, because anyway it's a length element, a line element. Okay. Okay. So see, as this EMF is equal to d minus d phi by dt ಬರೀತೀವಲ್ಲ. See, I will replace this E by this EMF E by in electric field minus sign over E dot dl line element. ಈ ತರ ಬರೀನಾ? Then that is equal to minus sign of d by dt ಅದು d by dt ಅದು. What is this phi? Is nothing but b into a. So if I want to calculate this b into a, so can I call this one as b into ds integration of Barla? This is also equal to b dot a because b dot ds. So I can rewrite that is b vector dot integration over ds vector. That is equal to b dot a. Just I will replace this part as like this. There is anyway minus minus cancel ಆಯ್ತು ಉಳಿತದೆ ಏನ್ರಿ ನಮಗೆ ಇಲ್ಲಿ. That is integration over e vector dot dl vector that is equal to that is d by dt of integration over b dot ds b dot ds. Then ನೋಡಿ ಇಲ್ಲಿ ಲೈನ್ ಎಲಿಮೆಂಟ್ ಅದ, ಇಲ್ಲಿ ಸರ್ಫೇಸ್ ಎಲಿಮೆಂಟ್ ಅದ. for line element to surface element to line element. So convert ಮಾಡೋದ್ರಿ from line integral to line integral to surface integral line element to surface integral. So we are going to use that is called as Stokes theorem. This is integration over that is if any vector E dot dl can be converted into surface by taking this del cross of E into ds. So it's by Stokes theorem we are going to apply this. So if I convert this one from this part, that is line element can be converted into area element. Therefore I will write that as del cross of E into ds is equal to that is d by dt of b into ds. Is that correct? That is integration. Anyway, this t term is and generally minus minus cancel ಮಾಡೋದು ಜರುತ್ತಿಲ್ಲ. Anyway, it's a EMF is defined as a mod. Mod ತಗೋತೀವಿ ಅಲ್ಲಿ minus ಇಲ್ಲಿ ತಗೋ ಜರುತ್ತಿಲ್ಲ. General ಆಗಿ ತಗೋತೀವಿ ಬಟ್ ಇಲ್ಲಿ ತಗೋಬಾರ್ದು. Okay. We get here minus and ಇದನ್ನು ರಿಟೈನ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ರಿ ಇಲ್ಲಿ. ಇಲ್ಲಿ minus and ರಿಟೈನ್ ಮಾಡೋಣ. ಇಲ್ಲಿ minus and ರಿಟೈನ್ ಮಾಡೋಣ. ಇಲ್ಲಿ minus and ರಿಟೈನ್ ಮಾಡೋಣ. Okay. Therefore, as we see, I can rewrite that one as del cross E integration over ds ಅದ. I can redefine that one as minus sign ಹೊರಗಿಟ್ಟು integration ಹೊರಗೆ ತಗೊಂಡ I can rewrite that one as db by dt into ds ಅಂತ ಬರಿಬಹುದು. Because ಟೈಮ್ಗೂ ಮತ್ತು ಏರಿಯಾಗೆ ಏನು ಸಂಬಂಧ ಇಲ್ಲ. Because time is can be taken into inside the integral. Therefore ಆ ಕಡೆನೂ ds ಅದ ಈ ಕಡೆ ds ಅದ ಇದೆಲ್ಲ ಕ್ವಾಂಟಿಟಿ ಹೋದ್ರೆ del cross E is nothing but ಏನ್ರಿ del cross E is equal to minus 2b by dt ಅಂತ ಬರಿಬಹುದು. 2b by dt or db by dt. So this is the same Faraday's law in terms of differential form. So this is Faraday's law in differential form. Faraday's law in differential form. Differential form. Is that clear all? Done. So either base ಮೇಲೆ Gauss law use ಮಾಡ್ಕೊಂಡು Gauss law of electrostatics, Gauss law of magnetostatics, then Faraday's law, then Ampere's law. So we can define Maxwell equations. That Maxwell equation part I'll continue in the evening class. Okay.